Hi everyone. Today we are going to go through graphing exponential functions, which can be a little bit tricky, but actually uses the same sort of transformations that we've been using all along. So hopefully it all kind of works together. You probably want your calculator and a note sheet. I will upload this note sheet into Google Classroom, so you can take notes on here if you want, or you can grab just sheet paper, whatever you want. So section title is graphing exponential functions, so we know we're graphing. Remember that when we're graphing, we really want to make sure we're going to focus on our inputs and then our outputs as we work through this to make sure that everything's super accurate. When we talk about an exponential function, so we have to think about, like, what does it mean to be an exponent? And usually when we talk about exponents, we mean something that grows to be positive very fast. Okay, so we can talk about something growing very fast, but then we can also obviously talk about something like breaking down and decaying really fast. So we end up with two options as an exponential function. One is something that grows really quickly, a growth, and then the second is more of a decay, so it's gonna decompose, fall apart, whatever you want to say. Okay, so when we're growing, we read from left to right, so we think of it as let's see, what fun color should we use? Turquoise? Does that look the same on here? I guess we'll find out. So grow means we're gonna shoot up to the sky, and a decay, because we read from left to right, means we're gonna shrink down to the ground. Okay. All right. So we have, this is kind of what we could call the sort of parts of our function, right? Not quite the parent function because it has no numbers, just has kind of our descriptors. And so I just put this in here. This was like really small and blurry, so I just kind of rewrote it. I put this in here so that you guys would have the opportunity to reactivate some of that information. So our A value, okay, A stands for the reflection. And then it represents if we have a shrink or a stretch. Okay, B is going to identify if we have a growth or a decay. H, just like before, is going to be our horizontal movement. And then K is going to be our vertical shift. So our vertical movement. Okay, so super big, really important stuff. Same thing as first trimester, so hopefully it all is still back in that memory of yours. Couple things here to remember with horizontal movement. Okay, so it's always the opposite of what you see. So if we have x minus 2, then the horizontal movement's actually positive 2, so we're going in that other direction. Okay, I have over here is like my big aha. Ooh, how do we know if it's a growth or a decay? Okay, if our B value is larger than 1, we're going to grow. Oops, sorry. If my B value is in between, so if my B value is larger than 0 but less than 1, then we're decaying, we're going to get smaller. Okay, so my B value is 2, growth. If my B value is 1/2, decay, so we're going to come down to the ground. The other thing to focus on is that this A value, he is outside in front of that base. Okay, so the big emphasis here is if you see a negative in your problem, the negative is the A. Your B, so these two buddies here, if you notice, greater than 1 and between 0 and 1. So my B value, in parentheses, something to remember, is never negative. The negative is actually the A value. Okay, so we're going to go through what really is kind of like the parent function. That's the function of f of x equals 2 to the x power. A lot of our functions don't really have numbers in them. It's like y equals x, or y equals, I guess, x squared is a cubed, or an exponent and x cubed, stuff like that. But your exponential function, that's the parent function, is f of x equals 2 to the x. Okay, and so we want to graph it. So the first thing we have to always identify, is it a growth or decay? So I'm just going to highlight, boom, the base. So the exponent is my x. The x is attached to that base of 2. And because 2 is larger than 1, that means that this particular problem is a growth. So when we think of it as a growth, we know we're going to start low and we're going to end high. So we're going to grow. Okay. The next are my y-intercepts, h and k, and then just an extra point. So let's identify h and k because those guys are easy. So h is kind of up here. So is there anything being subtracted from x? There's not. Okay, so my horizontal shift is 0. So for my parent function, I'm not going anywhere. My k is whatever's being added or subtracted at the end. So there's no number being added or subtracted at the end. So my vertical shift, my k, is 0. The next thing we want to do is we want to find out the y-intercept. So your y-intercept is always 0, comma, a number. Okay, so to identify what my y-intercept is going to be, we're going to plug 0 in for x. So we're going to go y equals 2 to the 0 power, and any number to the 0 power is 1. So my y-intercept as an ordered pair is 0, comma 1. Okay. The only time it's anything other than 1 is if there's numbers in your horizontal vertical shift or even an a value. Okay, and then the next thing we're going to do is we're going to figure out like what's an extra point that we could try so we can kind of graph with some accuracy. So I know that I'm at 0, comma 1, so I'm right here. I know it's going to grow up, so I'm going to pick, well, let's just pick 3. So I'm going to input the number 3. Okay, so x is my input, y is my output. So input the number 3, so I'm going to get f of x equals 2 to the 3rd power, which is equal to 8. So the ordered pair that I'm going to graph to help me graph with accuracy is 3, comma 8. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then knowing that it's an exponential means I know I kind of have this curve. So I kind of take these points. I'm going to slowly come up to my y-intercept, and then I'm going to escalate or grow, accelerate is probably a better word, to this guy. And that is the basic information. Okay, and a quick example. And I'm going to end this video and make a new one so it doesn't get too long with 2 problems that are a little bit trickier.